Hey, good afternoon. It's Danielle. I decided to do my oral report on how the immune system plays a role on Huntington's disease patients. Right now, there's not a lot of information on if the immune system correlates with Huntington's disease, but they do know that the inflammatory system does. So first I wanted to start by saying Huntington's disease is a neurological degenerative disorder. And right now there's no cure for it. So they're trying to do some research on different therapies that they could do and try and focus on where they can help. So a lot of other autoimmune disorders, neurological disorders, and allergy disorders have found some benefits and therapies through immune systems and where there's mutations and how they can assess them. So scientists wanted to take a look at the immune system in relationship to Huntington's disease. So their main focus is going to be on the invariant natural killer cells. And these are a group of regulatory T lymphocytes that secrete a variety of cytokines and play either pathogenic or protective roles in other diseases. And they wanted to see how these cells in the Huntington's disease development correlate. So what these scientists did, they took a group of mice that were infected with the Huntington's disease, and first they biopsied their tails to confirm that they did have the mutation. And then within that group, they separated them into two different groups. One of these groups is going to be injected with alpha gacer, which is that iNKT cell antagonist. So it's going to ramp up the cells. And then the other group, also infected, they're just gonna inject them with PBS, which is just a placebo, and they're gonna be the negative controls. So they spent 12 weeks on it. The first group that they were injecting with the alpha gacer, they weighed them and tested them every week. They did this to both mice, so they want to just track and notice where these changes are, if what's happening. So after the 12 weeks, they prepared the brains. So they obviously put the mice to sleep in a humane way with anesthesia, and they removed cells from the blood vessels, and then they sliced and incubated the tissues. Then the tissue samples were disassociated to generate single cell suspensions. That they're just making them into smaller pieces that they can get a closer look at. They're gonna filter them and wash them and get them stained so they can focus on those cells. So after this 12 weeks, they got the brain cells down to where they can put it on the petri dish. They incubated it, and then they stained it specifically for that iNKT cell. And the results were, after repeated activation of the iNKT cells with the A glacer in the Huntington's disease infected mice, showed a significant reduction in body weight compared to the placebo injected mice. And not only was there a reduction in body weight, there was also a reduction in brain mass. So this test did not work out in their favor. These findings strongly suggest that repeated stimulation of the iNKT cells with the A glacer mediated inflammation significantly contributed to worsening clinical symptoms, suggesting that immune activation can affect the severity of Huntington's disease. Now, although this test did not prove to be beneficial in maybe focusing more on how the immune system can help, it did provide evidence that these iNKT cells might be one of the critically important immune components in determining the disease progression of Huntington's disease. So overall, I think, you know, they definitely made some progress. They noticed, hey, this the immune system seems to be affecting other neurological disorders, and we've been able to find some ways to fix that there. So let's take a look at, you know, the immune system in Huntington's disease, and they found, hey, you know, the stronger the immune system is, the worse the Huntington's disease symptoms are getting. So, hey, let's not focus on, you know, making the immune system stronger, but maybe if we can weaken the immune system, maybe it can be beneficial in the future, is something to look at. So overall, it didn't work out in their favor, but it was knowledge that maybe there's a different path that they should travel down. And I agree with their findings. You know, I think if you don't know something, then you need to do some tests and study and see where your hypothesis leads you and maybe take a different direction. That's what science is all about. All right, thanks.